We have 183 people in the room at this point of time. This is wonderful. Let me please take a second and introduce Charlie Pelham, who is going to moderate the Q&A session. So Charlie Pelham joined BAE Systems in 2018. He brings 24 years of operational experience in service as an Army engineer officer. He holds a Bachelor's of Science in Mechanical Engineering, a Master of Science in Environmental Management, and a Military Master's of Arts and Science. He is currently part of the cohort for the Electronic Systems Business Winning Growth Leader Development Program. Welcome, Charlie.
Hi, welcome. Thank you. Again, I'm Charlie Pelham. I'm going to be your moderator for the BAE challenge statements. As I introduce each of the panelists to speak, what I will ask is if you have any specific questions, please use the webinar chat, and I will take a couple of questions from each speaker as they complete their question and have to give them time to answer them. I know if there's a lot of questions, I'm not going to be able to get to all of them, but however, you know, I will try to accommodate as much as we can given the time we have. So with that being said, I will introduce our first BAE Systems Challenge speaker, which will be Mr. Dave McWeeny. He represents the C4 ISR Analytic Systems as one of their technical directors. So Dave, I'll turn it over to you and I'll turn my video off.
All right, great, thank you. I'm happy to be presenting here today. I'm going to give an overview of our analytic systems product line and go through some of the things that we do here. So analytic systems, we provide analytics-based big data supporting the intelligence and geospatial data production for intelligence agencies, defense services, and allies. And what does that mean? There's a set of areas that we focus in. One is enterprise multi-ant content systems. And those are cloud-based data management and analytical services. And we process and facilitate sharing petabytes of GeoINT. I'll talk a little bit more about each of these in a little more detail, but just to give an overview. We also do geospatial production. This consists of producing rich geospatial feature data, charts, elevation content for civil, federal, and military operations. We also produce cybersecurity products. So these are accredited multi-directional cross-domain solutions and high assurance operating systems. Essentially, these enable networks, disparate networks to communicate with each other in a controlled fashion. And we also have advanced analytics. And so these consist of multi-int and multi-source intelligence, surveillance, and reconnaissance systems development and integration and sustainment. And so kind of all of these things together, if you look at that picture there on the right, our business is all about transforming data to information, to knowledge, to wisdom, and ultimately decisions for the benefit of our customers. We operate at all levels of this pyramid, and our objective is to move data and capabilities and enable people to rise to the higher levels of the pyramid so that they can make decisions from data more efficiently and effectively. Okay, so I'm going to talk a little bit about each of these four areas in a little bit more detail. Starting in the upper left right here, enterprise multi-ant content systems. So again, we do multi-petabyte content management. So this consists of imagery and other forms of intelligence from space and from airborne sensors. We manage that data and make it available to our customers. We do this using cloud-based software and data services. We also have capabilities for structured observation management. And what this means is either analysts, human analysts, or automated processes and algorithms might be processing data and analyzing imagery and making observations about what they see. So for instance, there's an airplane on the ground at the airfield in this location. And those are recorded in a structured fashion to enable further analysis and analytics in an automated fashion. And this enables us to relate observations and context from these sensors and sources to those known objects. And so we are a leading enterprise content management provider for modeling and analysis. So moving over to the upper right, we also produce geospatial products and services. So we produce foundation geoints. What does that mean? Topographic charts, terrain data, maritime charts, aeronautical charts, and standard products that we produce for civilian and government agencies. And that includes precision geoints for navigation. So very precisely locating features on the Earth to support navigation. We are a world-class provider of these geospatial products that support our customer missions. Moving on to the lower left, our cybersecurity products. So we have a number of products in this area. We have a foundational secure operating system that a lot of our products are based on that enable the government and our customers to have trust in the products that we do and trust in that software that performs that activity. And that includes one-way transfer solutions. So data can go from point A to point B, but not from point B back to point A. If I get my A's and B's straightened out there. We have access gateways that allow things like secure browse down and protocols like RDP, remote desktop protocol, across or between secure networks. And we have multi-directional solutions that do enable data to transfer in both directions. And these products protect the networks and environments where communication is essential. And then finally, on the lower right, are advanced analytics. So we support object-based production. And so this kind of ties to the structure observation management area as well, where our analysts are producing intelligence or information about objects or entities. So think people, places, things, and tying the intelligence and information and current state of the world back to those specific people, places, and things. And this enables activity-based discovery and analysis. So what activities are going on at the moment, or what activities happened yesterday, and how are those different? We provide capabilities for persistent monitoring and alerting. And we also have capabilities for statistical analysis of models for activity prediction. So this would be, the idea here is that an analyst might define, hey, here's activity A and activity B. And if both of those happen at the same location, maybe within a 50-meter radius, then we think activity C might be underway. And this allows analysts to build a picture of what might be happening in the environment so they can get a better understanding and be able to predict future activities. And so these enable advanced analytics for deep understanding and anticipatory intelligence. Okay, so that's kind of an overview of our analytic systems expertise, and you can kind of see we're doing a variety of things that again all tie to transforming data to decisions for our customers. And I want to talk about, I have a challenge statement out here. And if you think about the COVID-19 pandemic, which I'm sure a lot of us are thinking a lot about these days, it has exposed the need for advanced predictive pattern analytics. So if you think about contact tracing, or if you think about tracking the spread of disease, or you think about tracking people's behavior and patterns. So as governments and businesses begin to open up, what's going to happen? How will people change their activities and their behaviors, and what impact will that have on the spread of the disease? And so if you think about those kinds of problems, there's a need for analytics to analyze data, and those analytics need to be geotemporal aware, so geospatially aware and then temporally aware. They need to be attribute aware, so what are the attributes of the person's, people, places, and things, as well as attributes of the activities that are going on. They need to be relationship aware. So if, let's say, people are hanging out together, are they members of a family unit or not, or are they affiliated in some other way? What's the what's the transmission from a person, two different people or two different groups of people? And the analytics need to be movement aware, being able to track people, places, and things as they, as they move over time. These analytics will need to use machine learning and other techniques to look for the patterns of life in data, with the ultimate purpose being to predict future activity, including trends and changes in behavior. So these are the kinds of things that we're looking at. We're looking at solving these problems for our customers, and the COVID-19 pandemic is one example of a use case or a situation, but you can imagine other use cases and situations that could take advantage of the capabilities of these kinds of analytics. And we are definitely looking for partners in this challenge. You see my contact information down there at the bottom, and so definitely reach out if you think you can help us, and if you're interested in partnering with us. Okay, so that concludes my presentation, and I think we have a little bit of time for Q&A.
Okay, the chat's open for Q&A. The only thing I see in here so far is, and this goes back overall, is will we have all these slides that we're presenting, are they going to be available for the attendees to download or get to after the event's over? That's the only question I see right now. But
All right.
All right, I see some things coming in now. All right, one question, Dave, is who owns the IP?
That's an interesting question. I think there's IP on both data and both on software and analytics. I think the IP of the data is typically owned by the producer or the provider of the data, but that IP can be transferred via various mechanisms of licensing or purchasing or other agreements. IP on the software, the analytics, that is also a flexible topic. So as we look to collaborate with partners, there's a variety of models ranging from open source models to government source models to proprietary models and commercial models where companies and agencies can maintain intellectual property rights. And that is, that is a very hot topic these days. The government is very aware of different models for managing intellectual property, and like I said, I think there's a fair bit of flexibility and openness to different techniques for addressing needs of various participants.
Okay, here's another question. I'm going to jump over to the Q&A one. Does BAE have data sets available for analysis for the challenge statements for COVID?
Yeah, we don't have data available right now for this challenge statement. We would definitely be willing to work with a partner to identify what data you need, and then go out and find and help you find and gather the data that's needed for this.
All right, let's see. What level of readiness the technology needs to be considered for partnership?
Yeah, I'll take a first answer to that, and then Eric or others could chime in if needed. I think we're open to a variety of maturity levels, TRL levels, technical readiness levels. Doesn't have to be super mature, and we will look for the right opportunities to work with our partners and our customers to help mature the technology into the next stage that it needs to go.
Okay, and then the last question here, due to time, would be, is ISR, human-machine interface, and human-machine interaction an area of interest to your ISR team? And specifically, what challenges in this regard are you seeking solutions?
Well, yeah, absolutely. That human interaction is a huge challenge for us. you know, that permeates kind of everything that we do. How can we make these analytics that, you know, everything I've talked about is generally kind of, I'll say, back end focused, right? You know, algorithms and analytics and machine learning and things like that. But none of that really matters if you, unless you can present the data and the results of the analytics to end users in a way that they can understand, I'll say, you know, ingest or take in and utilize for their decisions. So that human machine interaction is very important. We are always open to new and different ideas for enhancing user experience and other approaches. So we're definitely open to hearing about that.
Okay. With that being said, hey, we'd like to thank Dave for coming out and kind of giving an overall update of what his challenge statements are. And with that, Dave, we're going to transition over to the next speaker. The next speaker is Rob Saracino from C4ISR Tactical Systems. He's also a technical director. So with that, Rob, I'll turn it over to you for your presentation.
Hey, thank you, Charlie. So, good afternoon, folks. Thanks for joining us today. My name is Rob Saracino, and I'm the technical director for the Tactical Systems product line within our C4ISR business. So I'll provide a real quick overview of our product line portfolio, and then really spend most of my time discussing potential collaboration opportunities for some of the dual-use technologies. My screen isn't there. We go. Okay, so Tactical Systems is a very diverse product line. We operate out of the Greenlawn, New York campus, which is out on Long Island, and it's comprised of these four distinct product areas. So just to be different, I'm going to start at 3 o'clock here on this clock and work my way around. So I'm going to start with our identification friend or foe business. So this is the largest part of our business here in Greenlawn, New York. Identification friend or foe, or IFF, is a cooperative ID system. It's used to prevent friendly fire. So it's a question and answer type system. It includes interrogators that ask questions, transponders that provide replies. So interrogators are one of the sensors that Eric mentioned as part of the collection segment of the TC Ped wheel earlier. The next product area is our mission computer systems business. And this product area produces the crew workstations and servers for the P-8 maritime patrol aircraft. The workstations and servers provide all the computing and network infrastructure for the 737-based aircraft, as well as the man-machine interface. So the P-8 system utilizes an architecture called ATCA, or Advanced Telecom Computing Architecture. And the reason I bring that up is it's the same architecture used by the telecom industry. So it's a pretty good example of a dual use, you know, something used in the military and as well as in the commercial market. Our optical ISR product area, it specializes in electro-optics and infrared wide area motion imagery systems. These provide high resolution day-night surveillance. And this part of our business has a really rich history of innovation in the optics field that dates back decades. And finally, the antenna product area. In this area, we provide and support other parts of the business, like the IFF business, as well as specialize in a couple of focus technologies. So anti-jam GPS and low radar cross-section apertures are some of the special technologies we have in our antenna business. While not a large part of our business, from a dollar standpoint, it's a strong contributor for us to winning programs across our enterprise. So next few slides, I'll dive a little bit deeper into each of the product areas. So starting off again with the IFF. And rather than focus in on one or two specific tech challenges, my plan here is to cast a pretty wide net of topics for potential collaboration opportunities. So we're mainly an ID product line. So any innovative technology for secure ID would be very welcomed. A small swap or size, weight, and power cooperative ID system that could securely ID a person on the ground and distinguish them from others. In other words, how can I securely pick out individuals from a crowd in day and especially nighttime conditions? And just to clarify, we're not actually looking for a system, but rather looking for technology that we could use to help advance our current capabilities. While I am shotgunning a bit here, if I were to focus on a single technology challenge, this would really be the one. This is an area of real focus for us. Quantum is another area of interest for us. Typically with quantum, people think about quantum computing. We're more interested here in quantum communications field and quantum sensing, actually. You look at processing, the bottom left there. So we'd also like to explore enhancing our processing capability. You know, many of our products utilize high-end FPGAs. The Zinc UltraScale Plus is an example of one of these. That FPGA includes 4 ARM processor cores. So anyone with expertise in supporting independent processing of these individual cores would be of interest, as well as those that may have expertise in high design assurance level certification, up to DAL-B. So these capabilities would help us with our certification efforts. Since we share the same link as the FAA's air traffic control system, this product area is very highly regulated, as you can imagine. And there's just some miscellaneous technologies I show here. You know, anybody working with gallium nitride transmitters, FPGA-based cryptography, chip scale atomic clocks, anybody starting to print flex circuits, or any technology that could help us reduce size, weight, and power of our current portfolio would be of interest. And that can be either reducing the size of our electronics or innovative thermal designs to help remove heat from our electronics as our power densities rise. On the mission computer side, very similar story. What was just discussed on the IFF side, we're looking for innovative thermal packaging solutions. Same issues here, especially in the high-end processing market, where really power densities are only really limited by the thermal constraints of the system. Also, a thing that's a little bit different with this part of our business is typically, like the IFF part of our business, antennas, we design, we build, manufacture, soup to nuts, we do our products soup to nuts. Whereas with the mission computer business, we have a slightly different model, and that will work with module suppliers and integrate these modules into specialized computer systems. And for that reason, we're always looking to expand our supply base, find agile, innovative partners that can support this business. So additional collaboration opportunities include open VPX expertise and fast prototyping of modules, especially processor cards, network switches, storage, interface cards. So those would be of interest to us. And then also the military market's no different from the commercial field in that there's a huge emphasis in improving cyber resilience. So BAE Systems has been a leader in this field, but there's always opportunity to advance our capabilities here. Multi-level security has a similar scenario. While BAE has considerable expertise in MLS, it's also an area where novel enhancements in this technology would be intriguing. So for the optical ISR part of our business, our strength really is in our sensor designs here. So enhanced image processing is an area we'd be interested in talking to potential partners about, whether that's improving the quality of an image or providing decision aids. So it's a big issue with data overload in systems like this. So decision aids and cues can be very beneficial. Eric mentioned earlier, actionable intelligence, that's really what this is all about. So again, so the operators don't get overloaded with data. Additionally, our business in Green Lawn has been suppliers of hyperspectral systems. Our systems tend to be on the high end, highly capable type, which tends to mean that, relatively speaking, they're typically a little bit more expensive. So we've been investing internal funding over the last couple of years to develop smaller, lower cost hyperspectral systems. So sensors that could be considered expendable or throwaway is our interest here. So we're interested in technology that could advance our development efforts in this area. And again, we are a sensor house, wide area motion imagery sensor house. So any technology that can enhance these products, specifically ones that, again, reducing size, weight, and power, also increasing sensitivity, or any improvements that could help us reduce cost. And then finally, you know, again, any development, focal plane, digital rope type development, beam steering, or any other really optical components that can help improve our sensor performance. On the antenna side, so our antenna products typically operate in the communication and navigation bands, you know, UHF, VHF, L-band. Our antenna team in New Hampshire typically works in the higher frequencies. The challenge in this domain is, as aircraft keep adding, you know, more and more sensors, they're really running out of real estate for apertures. So again, you know, the recurring theme here is reducing size. So working with metamaterials in aperture designs, that's one way to reduce antenna size. Metamaterials also have the potential to improve aperture performance, you know, whether it's wider bandwidth, increased radiated power, and so on. So metamaterial technology is a significant area of interest for this portion of our business. And I guess while I'm talking about, I'll jump to the bottom there while I'm talking about materials, any material science work associated with extreme environments could provide some opportunities for collaboration. I mentioned earlier that one of our strengths is anti-jam GPS antennas. So there's new applications for these type of antennas for, you know, very high performance aircraft that are have to survive in very hostile environments. So these products could benefit from high temperature radomes, high temp RF materials, adhesives, connectors, and so on. And then finally, mention their STAP algorithms. So space-time adaptive processor algorithms, if there are any innovative algorithms that could help us in our anti-jam aperture area. You know, we do a lot of controlled radiation pattern antenna work or SERPA work. We do have solutions in the GPS space with some other partners, but we always look to expand our SERPA systems to other places like comms and IFF. So again, very diverse product line. I think this product line has a tremendous amount of collaboration opportunity. I see a large overlap with what we do at Tactical Systems and what is done in the commercial sector and in this ecosystem that we're talking to today. So my contact information, as well as the contact information for our program manager that runs our particular business's innovation and growth organization, is included on the last page. So if you feel there's a technology that we could potentially collaborate on, feel free to either reach out to Tech Scouting Group, or you can reach out to the POCs directly that are on the last page. So appreciate your time and thank you. And I guess Charlie, if we have time remaining, if there's questions from the audience, I guess I can answer those now. Okay, so thanks, Rob. I'm looking in the chat right now, so if anybody has any questions, please feel free to go ahead and type your questions. I'll get to a couple of them before the next group. So, Rob, there is one question on here that came up while you were presenting, and what the question is: when you say printed flex circuits, do you mean 3D printed circuits? I do. So, you know, flex circuits have been kind of an issue for us over the years, in that, you know, in the manufacturing process, it's typically one of the more difficult components to manufacture. And quite frankly, I see that printing these with 3D printers, as I'm starting to see, might be a way to have a more producible module in the end. Okay, let's go down and see if we have some other questions here.
Does it look like, let's see, sorry. Okay, here's one for you. How has additive manufacturing impacted the way your systems are designed, and what kinds of collaborations are you looking for to advance your technology?
So I'll be perfectly honest as far as additive manufacturing. Yeah, we've started to just touch the surface. You know, certainly printed flex circuits is one thing we'd like to get into. We have done some experimentation with some of our chassis designs that have a lot of components and a lot of screws, because trying to hog these out of you know, aluminum becomes one, costly, and two, complex, and typically requires a lot of cost in the manufacturing portion. So we have actually experimented with a couple of chassis designs and have gone from, you know, chassis with probably 12 different sheet metal components down to 2. So we've done some work there, but certainly like to see a lot more work done in the future.
Okay, and there's one more you can answer here. Do you have small satellites in LEO monitoring for industrial security applications?
Eric, that might be might be more of a question for you. I don't know if you can pop in here. So that's in the tactical systems business. We typically don't deal in the space domain, you know, for the low Earth orbits. And again, some of the folks online, maybe Peter Simonson or Eric, might be able to answer that one better. So that might be a good question to save for the next speaker.
Okay, I will. With thanks, Rob, for your presentation here, and we're going to move forward. Our next speaker is Peter Simonson, who also works for C4ISR Space Systems as a technical director. And Peter, I'll turn it over to you to present, and I'll go to mute and we'll listen.
All right. Good afternoon. Let's see if this works. Okay. I'm assuming people can see my script, the slides here. So I'm Peter Simonson. I'm technical director with the Space Systems product line in C4ISR. And here. So what we build, what I'll call resilient mission payloads that have to do with space mission assurance, and I'll give a little better explanation what all those words really mean. We also have several different types of ground processing that support our customers that have resources in space. And we're also the leading provider of very high reliable space electronics. And we'll kind of give you a little bit of the history on that. And this cartoon just kind of tells you where some of our products live right now, and they're everything from on the surface of the Earth to in LEO and medium and geo orbits to interplanetary space. And we're providing basically processing resources, space grade processing resources for those, including the Mars lander and satellites around Jupiter and Saturn. That's sort of where the core of the space business has its heritage, but we have other capabilities now that we're bringing to complement it. So I'll talk about sort of there's several different areas that compose technology and market areas that compose space systems, and give you an idea of the breadth of what we do. So advanced mission payloads. We design and manufacture payloads for special missions looking for what I'd say information in the electromagnetic spectrum, RF and infrared, to sensors that look at Earth geophysical information and exploit that. In sort of some unusual phenomenology there. Space protection and control sort of has two aspects. There's capability that goes on spacecraft for self-protection, both from cyber and from external threat monitoring. There we have what's called secure enterprise communications, which is basically laser communication in a variety of places. Resilient ground systems sort of takes up two different aspects. We have, we build cyber resilient software frameworks for ground processing, so that we can handle, so that we are sort of the underpinnings or the infrastructure underneath a variety of ground processing systems. We also have a separate area where we have what I'll call massive scale signal processing for a particular customer. It's interesting, everything from custom hardware to cloud computing. And sort of the original core of the space business is space electronics technology, and that's everything from rad hard and rad tolerant semiconductor design to processors. We have, I don't know, there's probably 4 generations of space hardened environment for processing. Our current generation is a quad core, what do they call it? It used to be called PowerPC architecture for space applications. So this is sort of what we do. It's really kind of a sort of fascinating technology area. Okay, and we'll talk about collaboration and challenge problems. Okay, we're located in basically around the country, office in Merrimack, New Hampshire, and in Hudson, New Hampshire. The Manassas, Virginia area, where they actually build the semiconductor equipment. There's some ground mission engineering in Reston, Virginia, and a ground processing and analytics work in San Diego. These are just some of the things I can actually show you about our products. So obviously I've talked about there's over 1,000 rad-hard processors in space somewhere on orbit and beyond. We have a long heritage of building those. We build what we call digital receivers, which are really software-defined radio platforms for space. And there are a variety of different programs. As I said, the processing. We also deliver individual components for processors, memory, ASIC, application-specific integrated circuits, focal plane arrays for space qualified radiation hardened, and there's some circuit card assembly manufacturing for radiation hard or radiation tolerant processing. I can't show you all the other parts of the portfolio. The other thing that we've done is sort of bring standards-based computing into the space area. Historically, space has been well behind the rest of what I call the terrestrial industry. Of course, the whole new LEO thing is going to change that a little bit. But in terms of the ability to, the rapidity of delivering space resources. But we're a leader in the standards-based processing modules. One of the things we do is take work that the other parts of the company does in what I'll call terrestrial and airborne applications and put those into space control and resiliency, warning of different threats to space assets. We have a variety of the very high reliability processing. We continue to make company and customer research and development investments into a lot of these capabilities. And we have, like I said, a variety of these space to ground processing solutions, especially the resilient ground processing and large scale signal processing. So I wanted to talk about the challenge problems, because this is where I could really use the help of new start businesses and so forth. And they're sort of across the the gamut of capabilities. One is what I call modeling and models for single event effects. And the reason I'm interested in that is historically, the space business has to test every device that goes into a space application. That costs a lot of money, it takes a long time, and it has the unfortunate side effect of driving thought processes to let's use what already worked instead of innovating. So we're looking for this as a door to open innovation, okay, where we can use modeling and models that show what's called single event effects. For those of you that aren't familiar with that, that's when different particles, protons, heavy ions, so forth, from space penetrate into the semiconductors, and they can cause a variety of different temporary or permanent destructive events in the electronics. Another area we're interested in, companies that may have innovations here, is in packaging for space products. Historically, the space business has used what they call hermetic packaging, which is basically ceramic, glass, melted glass, and then ceramic. It turns out while it's really resistant to water vapor, it doesn't work very well as the clock frequencies go up in modern electronics. And so it's really become a problem. So anyone with innovative use and experience in what they call non-hermetic packaging in space, I'm very interested in collaborating with you. Another area is in radiation tolerant FPGA, what I'll call software-defined radio technology. A lot of the stuff that's being deployed now actually is from very old generation devices. Again, as I talked to, and they're adapted to go into space. Of course, that depends on the physical environment, which is which orbit you're in. But be interested in understanding and working with companies that have some innovative areas in this, especially for challenging space environments. Another area that we're interested in is in small size laser beam directors. So that's the thing that points a laser beam in a laser communications. And I'm looking for very accurate, what I'll call open loop repeatability. That is the ability to point the beam at the other side of a link in 100 microradian class. That's much finer pointing than you often hear, open loop. And so looking for that in a much smaller size beam director than we might have. The other area that's really ripe for innovation is low cost precision optical assembly. Historically, this stuff has been hand built like building a piano one at a time. And that's not necessarily a cost effective way to do this. And we're looking for repeatable optical assembly methods for small quantity complex designs. That's different than most automation, which is simple designs and lots of them. And these designs have to end up going in rugged environmental conditions, not necessarily a laboratory only. So any innovative companies that have novel ideas there, I'm very interested in working with. So again, you can reach me at peter.simonson@BAE Systems. And I'm very interested in hearing. Of course, you can contact everybody at the Venture Cafe, and they can get you in touch with me. Questions?
Okay, Peter, thanks here. I'm looking at a couple of questions here.
Sure.
One that's right on the chat is, would you have interest in space qualified low swap networking solutions?
Yes.
Let's see. And then there's one more question here that pops up. What are the current issues with modeling of single event effects that makes it unattractive to keep using?
It's not the modeling that's unattractive. It's the historical way where it was not modeled. And instead they said, we want test data. We've used test data is the only way. In other words, each device has to get radiation tested. That's very expensive. Okay. And what we're looking for is a modeling approach that be an accurate predictor of those effects, so that we can shorten the time from conceiving of the design to getting it deployed. And if you have capability like that, I'm very interested in talking to you.
Okay. Given the time here, we're going to move on. Thanks, Peter, for your presentation here. And for those that did get their chance to get their questions asked, if you could re-ask them again when we get to the challenge Q&A, we'll try to get those addressed at that point in time. But right now, I would like to turn it over to Dave Cooper, who's also a technical director at C4ISR Comms and Navigation Solutions, for his presentation. So, Dave, if you want to go ahead and get started here, and I'll go to mute and just listen.
I trust everybody could see my screen and hear me.
You're good.
Good. Yeah, anyway, I'm Dave Cooper. I'm from the CNS business in Wayne, New Jersey. I'm a tech director here and have been here for over 30 years. CNS is a world leader in digital data links and navigation systems. We have systems that are installed on many, many platforms across the world and many countries. They enable, there you go. They enable really our defense department and our defense platforms to talk to the allied platforms in a very, very standard format called Paddle J. Our wideband data links transmit very wideband data, hundreds of megabits per second for hundreds and hundreds of miles. And our landing systems and navigation systems provide non-GPS dependent navigation, which is becoming increasingly more important in today's environment. This is a pictorial of some of our data links that are on platforms across the world. On the upper left, it shows a system called SMIDS to JTRS. This is a 4-channel software-defined radio. It's on mainly tactical jets. And there are variants of this device on other kinds of jets. MIDS on the lower left, which is on older tactical jets. MIDS on ship, which is a larger data link, which is on surface ships, and TTR, which is a small data link on UAV platforms, and there are some other systems on ground platforms. One thing we had to do, this is a very large market spread across around the world, and so BAE Systems had a hard time addressing this wide market by itself. So we formed a limited liability company called Datalink Solutions, or DLS. It's really a partnership with Rockwell Collins over the last 30 years. And we jointly manufacture, develop, and do R&D for these data link systems under the DLS umbrella. This shows some of our major programs for communications and navigation. MIDS is a very large program. The program office, the MIDS program office in San Diego, purchases anywhere from $500 to $1,000 terminals per year, obligating up to $500 or $600 million a year in manufacturing of terminals. And one important point is they're obligated to give a portion of this money to small businesses for small business research and small business set-asides. And there are several interesting topics and challenges that this program office has. Common Data Link doesn't have a program office per se. It is more a distributed type of procurement model, and sort of the same with navigation systems. So the 800-pound gorilla in this is the MIDS JTRS program office with a lot of common R&D that's needed. As I mentioned before, our data links are interoperable. And so they're interoperable with our member partners. It's actually over 10,000 data links across the world. interoperating with platforms in 36 different countries. One problem the foreign nationals have is the complexity of our system. Something called the interface control document is over 3,000 pages. So there's a lot of different functions the system can do and will do, but you have to understand how to program it and set it up and how to troubleshoot it when it's not configured correctly. So the foreign nationals really need tools that will help them integrate Link 16 solutions on new platforms. Moving to our airborne navigation systems, we provide, as I mentioned, non-GPS navigation systems. In the lower left is something called a Doppler navigation system. So before the advent of GPS, helicopters navigated by looking at Doppler velocity changes during a flight. Over the period of years, we integrated GPS into the system and INS into the system. And now we have a resilience program to even make the capability more robust. In the upper left and lower right are landing systems. So these are systems that help aircraft land in Cat 3 or very low visibility conditions. And they have to be very precise. And again, they're non-GPS dependent. The upper left shows a altimeter box. And so when helicopters are taking off and landing, they have to very, very precisely know their altitude. We have a device that does this to inches. And often there are 2 of these per aircraft, so they get attitude of attack. In the lower system shows an aircraft carrier. And when aircraft land in this, they need both a primary and a secondary landing system. We provide one of those systems, and it synchronizes the aircraft yaw, pitch, and roll with the aircraft carrier motion, which is a very complicated problem. So the navigation solutions products span, as I mentioned, vehicle navigation, Doppler systems, and aircraft systems. And one technical or several technical challenges they have include what to do if GPS fails. So GPS is vulnerable to both deception and jamming and other factors. And the government and other agencies are looking for non-GPS dependent solutions, or they called APNT, Assured Position Navigation and Timing. So any solution that could enhance our current offerings would be highly desired. Another problem that helicopters have is controlled landing into terrain. In low visibility conditions, helicopters really have a very difficult time. This could range from emergency EMS helicopters trying to land on a highway during a snowstorm, or a military helicopter that kicks up a lot of dust during landing. So we have been trying to apply our low probability of intercept altimeter, which is the box in the lower left, to get a map of terrain and obstacles while a helicopter is landing. And generally, that problem is called degraded visual environment, or DVE. There's also a ever-increasing demand for data, as you know. Our common Datalink, or CDL, product line solves that problem on airborne and shipboard and ground platforms. Essentially, it forms a very, very wideband data link using a very directional microwave beam. It ranges up to 800 nautical miles. And this is key to get data back, from sensors that are remote to shipboard systems. So some technical challenges that I see is communications in a congested spectrum. One big issue is that the DoD sold off spectrum, the defense spectrum, to commercial telecom. And so this squoze all our communications into a narrower and narrower spectrum. So dynamic spectrum access, interference mitigation, signal processing and nulling is key here. Efficient use of processing resources is also key. So since our radios are software defined, we'd like to partially reconfigure FPGAs on the fly. We also would like to introduce new capabilities into our system without the burden of coding the software by hand, be it C++ or VHDL for FPGAs. And so we're looking for a very efficient autocode generation. As mentioned before, navigation is key. GPS is vulnerable, and assured position navigation and timing techniques are highly desired. Networking, our wideband data links are very directional. Since they're directional, the networking is not very robust. So we're looking at techniques to do really directional networking using new phased array apertures on the fly. And 3U open architecture is also highly desired in many of our systems. And other technologies include Link 16 for LEO satellites, free space optical communications, multi-band power amplifiers that span UHF, VHF, and L-band, and multifunction phased arrays are all technologies that we're seeking. And I did pull out a couple of sample SBIR problems that in the SBIR pre-release, and they span open architecture for common data link, model-based systems engineering for Link 16 out of the MIDS program office, LPI, AJ techniques for congested RF environments. Timing is very important, and so how do you maintain time in small platforms, and a portable atomic clock is highly desired. And lastly, on hypersonic aerial vehicles, there's a plasma that's very hard to communicate through, and how do you actually communicate through that type of environment. So, if you want to get a hold of me or Mike Alves, who's the business development contact, our contact information is here, and we look forward to hearing from you people.
Okay, Dave, I'm looking here on some questions, and let's see what we have for you. Okay, here's one. What are your thoughts on the DARPA now NSF2 funded Coliseum project that attempts to solve efficient spectrum allocations?
I'm not very familiar with that specific project, but generally, DARPA has been trying to address this through a series of programs. And there's generally a policy problem with even if a system like that works, the FCC has very tight regulations, and they don't fully trust a system like that. So really, testing and qualification, with other government agencies would be key.
Okay, and that's all really the questions I see. Let's see. Okay, here's a question here. Can you please elaborate on what you mean by being able to reconfigure FPGAs on the fly?
Yes, so currently our FPGAs are coded on startup, and so they contain a bulk of code. And rather than tear down the whole FPGA and rebuild the whole FPGA code base, we'd like to tear down a part of that code and then introduce a newer software-defined capability in that FPGA.
Okay. I think that's all we have on here for you, Dave. And with that, I know here we have some time for challenge for any other additional challenge Q&As. So if there are any questions specific to the panelists, then please type your questions in the chat. and or Q&A, and we'll try to answer the questions and let the panelists open up and answer some of your questions. Okay, here's a question here for any of the panelists that spoke. How will SpaceX and renewed space race impact BAE Systems?
Say it affords some interesting business opportunities. And so I would say in general, there will be financial interest in that.
Yeah, sort of tying back to my discussion about operating in all domains. Certainly the space domain is of key interest to us. Peter talked about our long legacy there, founded on radiation hardened technologies, among other things. Certainly some of the innovation that companies like SpaceX are doing to proliferate capabilities in space is of interest to us as we seek to make we and our customers seek to make broader use of that domain for the mission space that we spoke about earlier.
Let me look on the panel here and see what else we have. One question came up, and I don't know if this is, specific to anyone, but is BAE interested in partnering with companies relevant to the current ABM, Advanced Air Battle Management System? I don't know if anyone wants to answer that or.
Yeah, so we're familiar with that program. We'd definitely be interested in any company that thinks they have capabilities that are relevant to that program and may want to work with us in that regard.
Here. One question is, does BAE work with 8A companies? If so, who would be the best person to talk to? And this is an open question to anyone. Anybody want to answer that question, or let's see what else?
Yeah, I'm sorry, I don't know what an 8A company is, right? So that makes
It's a small. It's a small business.
But a special category.
In a special category.
Okay. Probably best to take that one offline. Maybe we can work with Francesca and the Venture Cafe team to get an answer out, just so it's get a thorough answer out on that one.
Okay, let's see what else we have here. Just got a new message here. Any interest in embedded system innovations, excuse me. I don't think that's a real question for any of the panelists to answer, so I will kind of skip that one. I think that's more or less for the tech scouting and venture cafe to answer that. So I'm looking here and I don't really see any other questions. Okay, here's one of interest. All right, someone wants to know about remote navigation planes and do you have interest?
Probably need a little clarification on that one.
Okay, hopefully the person who asked that question can, to work oceanography.
Oceanography. Yeah, so there may be some I'm not totally familiar with the specifics of this topic, but there may be some interest. I talked about our unmanned undersea vehicle business earlier on. So again, I'd suggest you reach out. Maybe we can have a little more dialogue specifically to see if some of these oceanography technologies that you're referring to would fit in with that piece of the business.
Okay. Let's see. Any other questions here? Okay. What ways is BAE Systems using artificial intelligence to solve today's problems, and what collaboration opportunities exist within your specific business area?
I think the use of AI probably touches all of our business areas. In the communication area, we're using AI to try to learn complicated signals autonomously using machine learning techniques. We also are investing in graphics processing units, so a key engine used in AI. And so we have the ability to run AI algorithms on many of our products.
Yeah, and I'll add to that. We have AI applications in a number of areas. We have one program that's looking at illegal fishing detection and detecting oil fracking construction sites. It's a kind of an early stage program that's looking at developing those kinds of algorithms and the data and data collection that's needed to support them. But yeah, to me, that's just the tip of the iceberg, and there's lots more to be done.
See. Okay. Here's one, and let's see. This says, in general, do you find that there is good alignment between current spectrum sharing research like DARPA spectrum collaboration challenges and our customer need? It also says Dave Cooper mentioned trust of AI being an issue. Can he elaborate?
Yeah, so in both of those areas, there's been a lot of dynamic spectrum access techniques and programs, both at the National Spectrum Consortium and at DARPA over the years. But the frequency managers, both in the DoD and the Army, Air Force and Navy, and also the FCC, they don't really fully trust how those algorithms are going to work. The other complexity is that the RF environment at point A is dramatically different than the RF environment in point B. So it's really hard in a network sense to figure out what the spectral environment is and how to do frequency reassignments. As far as artificial intelligence goes, there's a lot of people in the DoD that have issues with machine learning that doesn't necessarily come up with the same answer all the time. So they really like techniques that are more deterministic and that they could validate.
Yeah, I'll add to that. That yeah, trust of AI is definitely a challenge for our customer community. We're looking at things like PP&L, the pedigree, provenance, and lineage of the data and the training. How was the algorithm trained and what data was it trained on is another key thing that we need to be able to present to our users so that they can understand and then therefore trust the results of the AI algorithms.
Okay. There's a question here about to what extent is human-computer interaction a research interest, and who would be interested in that?
Yeah, I'll respond to that. Yeah, we talked about this a little bit previously. I mean, yeah, human-computer interaction and user experience is a very necessary part of making our analytics available and usable to customers and analysts to actually improve what they do and do that in a quick and efficient manner. So we are definitely interested in unique and novel ways of human-machine interaction. Things like virtual reality and augmented reality are things we're looking at, as well as traditional, and web-based user interfaces, and the whole user experience process is something we're deeply involved with as well.
Okay, here's a pretty interesting question. How does BAE deal with underwater communications links? And then what are the current challenges BAE is trying to overcome?
Yeah, that's probably one we need to circle back on and maybe answer via follow-up if we can.
Okay. Let's see. One more here. Are LiDAR systems of interest to BAE Systems, and in which domain?
Dave McWeeny, you want to talk about any processing there?
Yeah, we handle processing of some LiDAR data. So I think we kind of need to get a little more specific, understand the context of your question, and you know, we'd be happy to chat. You can reach out to me. I think my contact info will be available after this briefing.
Hey, gentlemen, I just want to thank you all for taking the time here. That was a large range of questions that we just answered. We want to take a short 5-minute break prior to our next session opening. How would you all feel about that? Yeah? This might be a good time to grab a beverage, go to the bathroom. I'm going to drop a link to our networking room. It's a pretty cool place. So if you want to go check that out, please do. Otherwise, we are going to resume the next session right on this same exact webinar link in about 5 minutes, and we will see you shortly. So thank you to all our presenters for taking the time to be here with us today, and thank you to BAE Systems. We'll see you shortly, okay? Take care.